In this session, we will have an idea about what is memory hierarchy. You can quickly recall in the first two sessions, we had a discussion on why we require memory, its purpose, about different types of memory, namely RAM that comes under primary memory and disk that comes under the secondary memory, and of course, the essential differences between the two. In the second session, we went into detail about the aspects of different types of RAM, namely static RAM, dynamic RAM. Within dynamic RAM, namely SDRAM, synchronous dynamic RAM, and rhombus dynamic RAM. And of course, also about ROM, read-only memory. We have to see the different types of ROM, so that we can discuss in the next session. In the current session, let us see the memory hierarchy in detail. Of course, you know about auxiliary storage or auxiliary memory is also known as secondary memory. Examples being magnetic tape and magnetic disk. Tape is sequential in access, whereas a disk, it permits random access. You can see both tape and disk are connected to your main memory. Why? Because the program and data stored in auxiliary memory or auxiliary storage has to be transferred to your main memory known as RAM, which is directly connected to CPU, and where the execution takes place. Once the execution is done, the resulting values are sent. We normally call them as a write operation from CPU to back to memory, your RAM or primary memory. From there, with the help of IO processors, it is stored on magnetic disk. Nothing but your hard disk. You know what is the purpose of CPU? Central processing unit. It is meant for processing your data. Your main CPU cannot take the load of IO data transfer or input-output data transfer. Therefore, exclusively, a processor has been dedicated to perform the IO operation. And that processor is called the IO processor, which can take care of all the IO operations. Now let us go ahead with your hierarchy. The auxiliary memory is at the outside. They are not directly connected with your CPU. See here, the auxiliary memory or secondary memory, in no way they have a direct connection with CPU. Whereas main memory is directly connected. We'll see what is cache memory a bit later. The cache memory is connected to CPU as well. And your primary memory is connected with your secondary memory, and IO processor is used as an interface between them. So IO processor is acting as an interface between secondary memory and the primary memory. Its job is to coordinate and control and perform, supervise, manage all the IO operations. Let us come to main memory. You know, main memory is also known as RAM, random access memory. When I say RAM, it is asynchronous dynamic RAM. Asynchronous means it is the read-write operations that are taking place in RAM. When I say RAM, dynamic RAM, DRAM, dynamic RAM, DRAM, they are not synchronized with your system clock. It is called asynchronous DRAM. When you come across asynchronous DRAM, again, there must be one more category called synchronous DRAM. We have already seen what is synchronous DRAM, where the reading or writing operation is synchronized with the system clock. If it is synchronized with the system clock, it is called a synchronous DRAM. If it is not synchronized with the system clock, it is called asynchronous DRAM. You know pretty well, you would have studied in IO organization, namely asynchronous data transfer and synchronous data transfer, we can recall. Synchronous means it is synchronized with the system clock. Asynchronous means it is not synchronized with the system clock. Okay, let me come to this point now. When you come across main memory, secondary memory storage capacity is in terms of terabytes. Even you can go from terabytes to even petabytes. When you come to main memory, its capacity is only in terms of its capacity is only in term of its capacity is only in term its capacity is only in terms of GB. Whereas when you come to okay, when you come to main memory, its capacity is in terms of GB. When you come to secondary storage, it is in terms of terabytes or even petabytes. And when you come to the another memory, which is called cache memory, which is acting as an interface between CPU and main memory. So IO processor is the interface between auxiliary memory and primary memory. And cache memory is the interface between your CPU and main memory. So main memory capacity is in terms of GB. Cache memory capacity is in terms of MB, megabyte. What is the purpose of cache memory? What is the characteristic feature of cache memory? The main characteristic feature of cache memory is the speed. See, RAM is your primary memory is faster than your secondary memory, and your cache memory is faster than your primary memory, and CPU is operating at the highest speed. So therefore, to minimize the waiting time of CPU, you make your data available from secondary memory to primary memory, thereby its waiting time gets reduced. We normally call them as the idle time of CPU. If the same piece of data is made available from main memory to cache memory, because cache is faster than main, the waiting time of the CPU or the idle time of the CPU comes down if the same piece of data is made available in cache rather than in main memory. Instead of CPU accessing the main memory, if that data is made available in cache, the CPU can as well get the data item from cache itself instead of accessing the main memory. Thereby, its waiting time can be reduced. When the waiting time of CPU is reduced, its productivity is enhanced. We normally call this as throughput. Its throughput gets increased. In other words, more amount of work is done by the CPU, more amount of work is done by the CPU. That's the meaning of throughput in a given time interval. Throughput is defined as the amount of work done in a given time interval. If the data is available, always made available in cache, it is able to do more throughput. It is able to do only to a lesser level if data is available in main memory. Why? Because main memory is relatively slow when compared with cache. I can give an analogy here. It is going to be in the ratio roughly 1:10. In the time assume you are going to take 1 second to access one data. In 1 second, you are able to get only one data item from main memory to cache. Whereas in the same 1 second, you can transfer 10 data items from cache memory to main memory. So which is better of the two? Transferring only one data item to the CPU, or processing only one data item by the CPU, or processing 10 data items by the CPU. In other words, you are making available only one data item from main memory to cache memory in 1 second. That's the analogy, or that's the example. Whereas this in the same amount of 1 second, you are able to transfer or you're able to give CPU or supply CPU 10 data items. Therefore, I can say your cache memory is roughly 8 to 10 times faster than your main memory. 8 to 10 times faster than your main memory. Therefore, if data is made available in cache, either it could be data, it can be program. If you are able to make it available in cache, you are able to reduce the idle time or waiting time of CPU, and thereby you are improving its efficiency or performance. Namely, the throughput factor is increased. So this is about the memory hierarchy. Remember, my auxiliary storage capacity is going to be in terms of terabytes or petabytes. It is very, very, very slow in speed. Tape is the slowest device, and disk is reasonably better. Its access time is going to be, or speed is going to be roughly of the order of 10⁻³ seconds or milliseconds. When you come to main memory, it is going to be of the order of nanoseconds. When you come to cache memory, I told you it is 10 times faster. Therefore, it is faster than cache memory is faster than main memory, and main memory is faster than your auxiliary storage, and CPU is faster than your cache memory. Therefore, to match the speed of CPU, we don't have any storage available or any memory available. To minimize the speed difference, to compensate the speed difference between the main memory and CPU, we have one more memory that is sitting as the interface between CPU and main memory. That memory is called cache memory. Of course, you can recall cache memory is based on the principle of static RAM. You know, in a RAM, there are two types, static RAM and dynamic RAM. Static RAM is made up of transistors. You know pretty well, to store 1 bit, it will make use of 6 transistors. Whereas in the case of dynamic RAM, which requires refreshing, to store 1 bit, it uses only 1 transistor. And static RAM is faster than dynamic RAM. I told you in the previous session, it could be roughly in the ratio 1:7 or 1:10. The same analogy holds good. Main memory is made up of dynamic RAM, whereas cache memory is made up of static RAM. This uses transistors and this uses capacitors. Here the capacity is more, whereas here the capacity is less. This is in terms of terabytes. This is in terms of gigabytes. Auxiliary storage capacity is in terms of terabytes. Quickly, let me summarize. Your main memory capacity or RAM capacity is going to be in terms of GB, gigabytes, and your cache memory capacity will be in terms of megabytes. And what is the main characteristic feature of cache memory? Its main feature is going to be only speed, 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 and speed. That's all. That's the feature of cache memory. And since its capacity is very, very less, we are not going to stand for the entire memory data available in main memory to cache memory, because this is in GB size. This is going to be in MB size. Therefore, what we can do, you can transfer only a portion of data that is heavily demanded by the CPU at a particular point of time. And this is based on the concept. If you have studied operating system, if you know about operating system, it is based on the property referred as what we normally call them as locality reference property, or property of locality reference. So that is a principle based on which you transfer data from main memory to cache memory. That is called as the locality reference property. So based on that property, you transfer a block of data. When I mean block, it's a small chunk of data from main memory to cache memory. Thereby, CPU need not access main memory at all. It has to get the data from cache itself. We don't call it as a data, we call it as the word. You know what is a word? A word is equivalent to word length. A word length is nothing but how many bits a processor can handle at a time. You say 8-bit processor. In the case of 8-bit processor, the word length is 8 bits. In other words, it is called 8. A word is equivalent to 8 bits. In the case of a 16-bit processor, the word length or word in short is equivalent to 16 bits. Therefore, if the word is made available in cache, CPU need not worry about the presence of main memory. Its request is satisfied by the cache itself. Thereby, the performance factor gets increased. That's the basic idea behind the presence of cache. It is based on the property of what locality of reference. So that is the basic point you have to keep in mind. When you come across cache memory, we can discuss in detail. So thanks for your time now. In the next session, we will discuss about the different types of ROM.